Hello everyone, today we're looking at another intermediate geometry problem. And you might even be wondering, like, why am I even doing videos at this point? I'm just doing one problem a day. That's like a 2-minute video. Well, this whole thing is really just to keep my doing a little bit of math every day streak going. So like, if I have to make a video every single day, I have to do a little bit of math every single day, no matter how much homework I have. So just kind of keeping the streak going. Anyways, today the problem is actually, I think, quite fun. So we have a triangle inscribed in a semicircle with radius r, so its base coincides with the diameter, and the point C does not coincide with either A or B. And the graph is right here. Okay, and C does not coincide with either A or B, so it's like that. And then S is AC plus BC, then for all of permeable position, we try to find which one of these inequalities or equalities is satisfied for all positions. So let's take a look. So C is not an A or B, and then it's obviously a right triangle because AB is the diameter. And I'm just going to use VS Code as scratch paper again. We know AB is 2R. So according to Pythagorean theorem, AB squared is obviously... No, actually, let's start with S. S is AC plus BC, according to the problem. AC plus BC, so since we're trying to find the relationship between S squared and R, S squared is just AC squared plus 2AC BC plus BC squared, right? AC squared plus BC squared is obviously just AB squared, which is just 2R squared, because AB is the diameter, which is 2R. So this is just going to be 4R squared. And now we can conclude that S is greater than or equal to 4R squared. However, that is not an option, so we have to go even further and look at the other part of this equation, which is 2ABBC, which I should probably write down more explicitly. 2 times AB times BC. Okay, now it just looks like pointers of C++. And now let's take a look at what AC and BC can be at most. Because right now we realize that D is obviously wrong because it's already proven to be greater than or equal to 4R squared. And E is probably also wrong because AC times BC is probably not always 0. Now it's just up to the relationship between S squared and 8R squared. And let's just see if the maximum value of S squared can exceed 8R squared. Because if it can, we can just determine it's C. If it can't, then it's either A or B, judging by how much it exceeds by. So let's take a look at the maximum value S can take, which is now the maximum value 2 times AC times BC can take, because we already determined the value of the other part. It's just going to be 4R squared. So how do we find the maximum value of AC times BC? Right now, AC and BC are just two completely random values that can move in any way it wants, not having to worry about the other one. However, we can rewrite them into one relationship, and this is the most fun part of this problem. We can rewrite them in terms of area of this triangle. Area of this triangle is just AC times BC over 2, right? And the maximum area of this triangle with AC over BC, with AC times BC over 2, is just putting C on the very top of this dome. And the maximum altitude is just R. And we know the maximum base is also 2, well, not maximum base. The base is always 2R, and the altitude at max is R. That's when C is at the top. So the area of this triangle at max is just R times 2R over 2, which is just R squared. That is the maximum area. And since we know 2ACBC is equal to 4 times that part, which this part is the area, which is equal to R squared. So the maximum value of 2ACBC is just 4R squared. And knowing that, we know the answer. We know that the maximum value can be at most 8R squared, and it can be smaller than that when C is not at the top and the altitude is less than R. So the answer is A. S squared is less than or equal to 8R squared. Okay, so that is the only problem we're doing today because I'm running out of time. And yeah, I'm just trying to keep the streak of doing a little bit of math every single day going. And also, you can realize that I'm not doing the geometry problems in order because I realized that the older ones, I don't have enough time to actually figure them out. They're a little bit harder. And I just did the ones that I actually took notes on, such as this one, because it's actually kind of fun. Anyways, hopefully you'll see you tomorrow. I feel like my streak's been going pretty well for the past, like, at least half a week or something like that. So hopefully with a high chance that I'll see you tomorrow in the next boring video of just one problem for an entire like 2 minute long video.